And I would like to welcome Ayako Tsuchiyama from the United States on stage. Sorry? From Japan. From Japan. Sorry, from Japan.
Okay. Sorry, I'm from Japan. Hi everyone, my name is Ayako Tsuchiyama from Japan. My research topic is related to earthquakes. The reason why I choose this topic as my research project is I have experienced earthquakes so many times since I was born in Japan. But I'm not sure whether you're familiar with this topic or not, so before starting my presentation, let me ask you one question. How many of you guys have ever experienced earthquakes before? Please raise your hands if you. Oh, some of you might have experienced that. Thank you. If I ask the same question as this in Japan, everyone would raise their hands. So actually, we have experienced earthquakes more than 2,000 times in 1 year, all over Japan. So here is a big difference between our country, Sweden and Japan, in terms of a seismic background. So first of all, let's look at the map and see the places where earthquakes mainly occur around the world. So this map shows the epicenters of the earthquakes around the world in 2017. The color means their depth of a hypocenter. For example, red dots occur in a shallower region, and blue dots occur in a deeper region. Anyway, could you find Japan on this map? Could you see Japan? No? The answer is no, because Japan is completely hidden by so many earthquakes on this map. But you may find Japan is located on the center of this map, and you may find there are some different colors plotted on this map around Japan. So that's the key point of my research project. My research project is focusing on these kind of blue dots. Blue dots are deep earthquakes. So what exactly are deep earthquakes? According to seismic definition, it's generally defined as a quake at the depth of greater than 300 kilometers. So these kind of earthquakes occur in a very deep area, so still we have not identified the mechanism of them. But if we could figure that out, how to generate deep earthquakes, we will be able to reveal the history of the Pacific plate, because most of the deep earthquakes were triggered in subduction zone along the Pacific coast. And also, moreover, in several years, huge earthquakes were triggered by the Pacific plate. So what I want to say here is my research result will be helpful in the future for many countries, such as Japan, the United States, Chile, and any other countries located along the Pacific coast, and also for many people who are suffering from natural disasters like tsunami. So here, I would like to tell you how to detect the peculiar features of deep earthquakes. I usually use a bunch of waveform data recorded by seismograph. The seismograph is a device to detect the motion of the ground, and this is a picture of the seismograph. And in Japan, the seismologists and the students can use these waveform data freely, so I can use this data, and I analyze this data and try to figure out the mechanism of deep earthquakes. So let's look at an example to make you understand how to analyze these waveform data. There are two actual waveform data recorded by seismograph, and these two waveforms were generated by two different earthquakes at a different time. But if you compare them like this, it's almost the same. It's amazing, right? Although these two different earthquakes occurred at a different time, but their waveform data recorded at the station is almost the same. So that means probably these two earthquakes were triggered at the same place under the ground. So here's the result of my research project so far. My research group found two clusters of earthquakes showing waveform similarities for the first time in Japan. But also there are some different kind of interpretation or discussion about my research project. So if you're interested in my research project, please come to my poster. And also I have a souvenir from Japan, and also I have prepared for some quiz about the earthquakes. So if you got the perfect score on my quiz, then you can gain some souvenirs from Japan. Thank you.
Thank you very much. Are there any questions?
Oh, over there.
There's a question down here. Ah, okay. Up there as well? Okay. And maybe we also applaud after answering all the questions. Then otherwise down here. Okay.
I would say in Swedish language. Okay. I was wondering about the earthquake. Is there any way that you can know, for example, before the earthquake takes place, that it will take place? And is there a way you can try to prevent the chaos that can take place?
So your question means, can we predict the earthquakes?
Indeed.
That's a good question. But actually, our answer is no. Because it's the phenomena of earthquakes is really difficult and complicated. So still we cannot predict the when or where the earthquakes may occur. But I cannot say in the near future, but in the far future, this kind of my research project will reveal the mechanism of the deep earthquakes or any other kinds of earthquakes. Probably we will be able to do that, but I'm not sure.
Okay. There was one more question down here. Ah, there's one more over there. So you'll be the next questioner.
Thank you for the interesting presentation.
Thank you.
My question is, so we've learned that we don't have the ability to predict the earthquakes before they happen. So what are the efforts that cities can make to deal with these earthquakes that happen?
Your question means in Sweden?
No, in like all of the world, like Tokyo or California or anywhere, what are the efforts that the cities can do to change the infrastructure to help deal with the earthquakes when they happen? So,
yeah, I would like to explain about the in Japan. So in Japan, as I said at the first spot, we have experienced so many earthquakes now. So actually, all the buildings were constructed by something, there is a really strict law to construct new buildings. So actually, what I want to say is it's really important to know all of the people living in those kind of country to learn about how to escape from the disasters when it occurred. And so I think the education is really important. And as a young scientist of seismology, I feel I have to teach you about any information of earthquakes here. So please come to my boss there.
Okay, maybe the last question down here. And then the rest can come to her poster, and then afterwards you can ask more questions. I think it's him. Yeah.
There's a lot of questions.
Hello. Hello.
Hello.
So I wanted to know more about these waveforms of the movement of tectonic plates. So since you only have such a limited amount of samples, do you think that your results may contain inaccuracies of these waveforms, or do you think that it's already well established that the waveforms will be predicted to move in a certain kind of way?
Can I check the question?
Could you maybe reframe the question in a shorter way?
So essentially what I'm asking is, do you think that this problem needs more research, or do you think that the movement of the waveforms can already be very predictable?
Actually, my answer is no, because here I have analyzed only the earthquakes which magnitude is greater than 3.0. I mean, it's kind of a middle class of the earthquakes, because we want to use the clear waveform data, so it doesn't include some smaller earthquakes here. So we have to add more earthquakes data into my research. That is my future work, and then maybe I can establish the the comprehensive theory of the earthquakes mechanism. So that's my future work.
Okay, thank you.
Okay, thank you very much. Okay, thank you. Okay.